Good morning one and all. Now in previous lecture we have seen estimation parameters which were estimated from the year 2020 to 2030, and all these estimation parameters are collected from one of the ITUR recommendation. We have seen different estimation parameters which were estimated from the year 20 to 30, and these were collected from one of the ITUR recommendation. Now coming to this lecture, in this lecture we will see the different operating scenarios of 5G in detail. Nothing but different application scenarios that are handled by the 5G that we will see in this lecture in detail. Now coming to the first slide, now here we have 5G usage scenarios, right? Now the 5G usage scenarios, nothing but the application scenarios that are handled by the 5G, those were represented in this particular slide. Now what are the different 5G usage scenarios we have are, one is tactile internet, right? Tactile internet, machine type communication, great services in cloud, gigabit wireless, IoT, and IoT is nothing but Internet of Things, as you already know. And next usage scenario is super real time and reliable. These are the different 5G usage scenarios, nothing but the application scenarios that are handled by the 5G. We will see one by one in detail. Now coming to the first usage scenario, we have tactile internet, right? Now this tactile internet is one of the usage scenario of 5G, through which a user, that means we are the user, through which user can access internet at very less amount of delay. A tactile internet is an application scenario that is supported by the 5G, through which user can access the internet, that means internet accessing by the user at very less amount of delay time. This is the main motto of this particular tactile internet, nothing but the very low response, as I have represented over here, very low response time, nothing but user should get access to the internet at very less amount of delay time. This is the main motto of the tactile internet, and this through this tactile internet real time control of mechanism of devices can be done. Through this tactile internet we can control the devices, mechanism of devices under the real time. And next, it provides very high bandwidth. Tactile internet provides very high bandwidth. These are the features of tactile internet, right? Now this is the first usage scenario of 5G that we are discussing now, that is tactile internet, nothing usage scenario or the application scenario that is handled by the 5G. Now through this tactile internet, user should get access to the internet at very less amount of delay time, and this tactile internet through which we can control the real time, we can control the mechanism devices under real time, and this provides a very high bandwidth. Tactile internet provides very high bandwidth. These are the features of tactile internet. One is internet access should be done by the user, accessing to the internet is done by the user at very less delay time. That is one of the feature of tactile internet. And another one is the through tactile internet real time control of mechanisms can be done. That is one more feature of tactile internet, and it provides very high bandwidth. These are the features of tactile internet. Now coming to the second usage scenario or the second application scenario that is handled by the 5G is machine type communication. As you already know, machine type communication is nothing but delivering the data or the delivering the data between machine to machine. That means you are transferring the data, that means accessing between machine to machine only. User won't interfere within within this particular communication. There is no interference of the user or the human. Under machine type communication, the access is between the machine to machine only. We are transferring the data, that means here transmitter is machine only, receiver is also machine only. There is no interference of the user, or a human. There are some features of machine type communication, right? Now since this communication is supported by the machines only, that should support for more number of days. Those machines which are under machine type communication should support for more number of days. That's why it has a feature of very high battery life. That means the battery life that is given to the machines under machine type communication should be very high. Now coming to the next feature, it should be low cost device. Whatever the machines that we are operating under the machine type communication, those should be of low cost device, and it should be of simple network management. These are the some features of machine type communication, right? And it should also support low complexity. Another feature of machine type communication is low complexity, and these are some features of machine type communication. What is machine type communication? You are transferring or processing some something between machine to machine only, right? We won't have any user interference or any human interference in this particular communication. Now this was absent in previous generation system, nothing but 1G, 2G, 3G and 4G. Up to 4G, 1G, 2G, 3G and 4G doesn't support machine type communication. This was the extra usage scenario or the application scenario that is getting added into the 5th generation system. Now through this machine type communication, you are transferring the data between machine to machine only. The communication is between machine to machine only. What is machine type communication? Here the communication is between machine to machine only. There is no interference of the user or there is no interference of a human being. Now this machine type communication have some features. Now since this machine type communication, under machine type communication, the communication is between machine to machine. Now that should support for large number of days, nothing but more number of days. This machines has to support for more number of days. That's why it should provide with very high battery life, and the cost of the device should be low, and the simple network management should be simple, and it should be of low complexity. These are the some features of machine type communication. Now coming to the next usage scenario, here we have great services in crowd, right? We have some places where large number of people gather, like open air festivals we have, shopping malls we have, and some stadiums we have. These are the places where there is a chance of gathering more number of people, nothing but very high user density. Very high user density is nothing but places where there is a chance of gathering more number of people. Now at that place this 5G it should provide its services. It should provide its services in crowd is nothing but the places where there is a gathering of more number of people, nothing but very high user density. Now at that place it should provide its technology flexibly. This is one more scenario of 5G. That means the places where there is a chance of gathering more number of people. See, if you see 4G or 3G, now present generation is 4G. Now if you gather at a place like stadium or open air festivals or a shopping mall, now the signals of your mobile will get fluctuate, right? Now this you are overcoming under 5G, right? We have a chance sometimes of not connecting the calls to the other members if you gather at a place like open air festivals or shopping malls or the stadium. That means if you are gathering at a place where there are more number of people, at that place we may not connect to the other person, we may not connect a call to the other person. In the present generation, nothing but the 4th generation, this was absent. Now this particular scenario is supported under 5G. That means 5G will provide its services though there are more number of people in a given area. Nothing but if a given area is having more number of people, at that place also the 5G can give its services to the user. That is the one of the usage scenario which was absent in the previous generation like 4G or 3G. Now coming to the next usage scenario, we have gigabit wireless, right? Next usage scenario we have gigabit wireless. The name itself indicates gigabit. Gigabit is nothing but very high rate, very high data rate, right? Now it is followed where we require high amount of data rate. This gigabit wireless scenario is followed where we require high amount of data rate. Now this was used in the millimeter wave technology, which was newly coming technology, millimeter wave technology, massive MIMO. These are the places where we are using the gigabit wireless. That means where we require high amount of data rate, right? Where we require high amount of data rate. Now coming to the Internet of Things, as you already know, Internet of Things. Now that is one more usage scenario of 5G. And next we have super real time and reliable. Super real time and reliable. Now this is one more usage scenario of 5G. Now it has low latency. Now it has low latency and highly reliable. The 5G scenario, this is one more application scenario that is supported by the 5G fifth generation communication system, providing a very low latency and high reliability, providing very low latency and high reliability. These are the different scenarios. What are the scenarios we have? We have tactile internet, machine type communication, great services in cloud, gigabit wireless, internet of things, and super real time and reliable. Coming to the tactile internet, now through this user can access to the internet. That means user can access to the internet at very less amount of delay time, and this is one of the main motto of the tactile internet, that is internet accessing is done at a very less amount of delay time. And next feature of tactile internet is, through this tactile internet real time control of mechanism of devices can be done, and it provides very high bandwidth. These are the features of tactile internet. Now coming to the machine type communication. What is machine type communication? Communication is between machine to machine. That means there won't be any user interference or the human interference. Now this machine type communication have some features like very high battery life, low cost device, low complexity, simple network management. These are the some features that are to be supported by the machine type communication. Now coming to the next usage scenario, we have great services in cloud. Cloud is nothing but very high user density. Places like open air festivals, stadiums, shopping malls. These are the places where you can see gathering of more number of people. At that places also the 5G can provide its services flexibly. Now, and next usage scenario we have gigabit wireless. Now this particular usage scenario we are using where we require high amount of data rate, like we have millimeter wave technology, massive MIMO. These are the places where we are using gigabit wireless. And next we have internet of things, as you already know what is IoT. And next usage scenario is super real time and reliable. That means it should provide low latency and high reliability. These are the different usage scenarios of 5G. Now coming to the next slide. Now so overall there are various kinds of scenarios. We have seen various kinds of scenarios like tactile internet, we have seen machine type communication, great services in cloud, and another one is gigabit wireless, IoT, and next we have super real time and reliable. These are the different usage scenarios that we have seen till now. Now that means there are various kinds of scenarios which are to be addressed, and this require various technical requirement. Now this whatever the scenarios that we have discussed till now requires various technical requirements. Now this 5G is to provide support, like it should give a very high bitrate. What is the 5G should support? It should provide to support, the 5G is to provide to support very high bitrate and nothing but very low delay. Bitrate should be high and delay should be low, and accessibility for large crowds, volumes in small area. That means within a small area, if more number of people are present at that places also 5G should provide its own services. And wide coverage area, this is one more thing that is to be supported by the 5G. Wide coverage, it should provide coverage to maximum amount of distance. And next one is high reliability, and 5G should give fast result. Like all these things whatever we have discussed 5G scenarios, those were represented in this form. Again the same thing is represented over here, right? Now what 5G has to support, it should provide high bitrate, right? It should provide high bitrate, low delay, and accessibility for large crowds, volumes in a small area, wide coverage, high reliability, and it should give fast result. These are the some things that are to be supported by the 5G. Some things that are to be supported by the 5G. Now if we go for air interface, nothing but if we go for air interface, there are various things that are provided by it. For example, it should provide 10 times of throughput. Behind these supportings like high bitrate, low delay, accessibility for large crowds, wide coverage, high reliability, 5G should give fast result. Behind this supportings of 5G, behind these things that are to be supported by the 5G, we have some more things that are to be supported by the 5G. Those includes it should provide at least 10 times the throughput of earlier generation. That means if 4G is providing a throughput of some value, some value into 10 throughput should be provided by the 5G. That means it should provide at least 10 times the throughput of earlier generation like 3G or 4G. Now it also expects to decrease the latency by 10 times. The latency, as we have already seen, it should provide very low delay. That means latency should be decreased by 10 times to provide tactile internet services and machine type communication. Because the low latency, through low latency only uh, we can go for the usage scenarios of tactile internet and machine type communication. That's why the latency is to be decreased by 10 times with earlier generation in order to provide tactile internet and machine type communication. It also expects to increase the connection density by 10 times. That means more number of devices. The 5G should support connection density of 10 times if you compare with the previous generation system. It also expects to improve spectral efficiency by 3 times, right? We have to improve the spectral efficiency, whether it may be anything value, we have to provide better services than the previous generation. What I want to conclude is it should provide the coming generation, either it may be 5G or the future generation 6G, it should provide better services than the previous generation. Now that includes a very high bitrate, very low delay, and accessibility for large crowd volumes, and wide coverage area, high reliability, and it should give fast result if you compare with the previous generation, and it should provide high throughput, and it should provide low latency, nothing but the low delay, in order to provide tactile internet and machine type communication, and it should get connected to the more number of devices, and it should improve its own spectral efficiency. And next we have traffic capacity. It should handle more amount of traffic. It should handle more amount of traffic, and the cost should be get decreased. It aims to decrease cost per bit, and it expects 100 times of network efficiency. These are the some things that are to be supported by the 5G. These are the some things, some values, some parameters that are to be supported by the 5G, right? All these things we have represented in this particular slide. Now once again we will discuss what it has to provide is anything. The value may be anything, but the 5G should give a better result if you compare with the 4G. The main conclusion is that the 5G should give better result if you compare with the previous generation system, right? Now what it should support, the 5G should support very high bitrate. That is the one thing that if you compare with the 4G, the 5G should support very high bitrate. Now if you compare with the 4G, the 5G should provide very low delay. It should support very low delay, right? Now first thing is it should support very high bitrate, right? If you compare with all these supporting parameters, whatever the parameters that are to be supported by 5G, those parameters are in comparison with the previous generation system, right? Whatever we are saying that these parameters should be supported by the 5G, those parameters are in comparison with the previous generation system, nothing but 3G or 4G, right? Now what are the things that are to be supported by the 5G? We have different parameters that are to be supported by the 5G. First one is very high bitrate. The 5G should support very high bitrate, and 5G should support very low delay, and 5G should support accessibility for large crowd volumes in small area, and 5G should support wide coverage, and 5G should support high reliability, and 5G should give fast result, and it should support high throughput, right? It should support high throughput, and it should support low latency, nothing but low delay only, very low delay only, in order to provide tactile internet services and machine type communication, which are nothing but the usage scenarios of 5G. And it should get connected to the 5G should get connected to the more number of devices. If you compare with the 4th generation system, 5G should get connected to the more number of devices. That is one more parameter that is to be supported by the 5G. And it also expects to improve spectral efficiency. Spectral efficiency should be improved, and network efficiency should be improved. And next we have, it should handle more amount of traffic. If you compare with the 4th generation system, 5G 5G should be in a position to handle more amount of traffic, and it aims to decrease cost per bit. The cost per bit should be decreased if you compare with the previous generation system, right? These are the some parameters that are to be supported by the 5G. The first one is high bit rate, low delay, accessibility for a large crowds, large amount of people, more accessibility for more amount of people in small area, and wide coverage area. It should support wide coverage, high reliability, fast result, throughput should be high, it should spectral efficiency should be improved, network efficiency should be improved, and connection density, nothing but number of connected devices should be more. And next one is low latency, in order to provide tactile internet and machine type communication, and it should be in a position to handle more amount of traffic, and the cost per bit should be decreased. These are the some parameters that are to be supported by the 5G, right? Now we have seen 5G scenarios and what are the parameters that are to be supported by the 5G in detail we have seen till now, right? Now coming to the gigabit wireless, we will see usage scenarios one by one, right? We will see usage scenarios one by one. Now this gigabit wireless, where we are using this gigabit wireless, this is used where we require more amount of data rate, right? Gigabit wireless is used where we require high amount of data rate. If you see this figure, right, if you see here we have dense urban information society, nothing but now it is a place where where we require, this is a place where we require high amount of data rate. Now this at this particular place, this gigabit wireless scenario provides amazing end user experience provided by high data rates, right? Now this is a place, the future we may expect this, right? This is a place where we require high amount of data rate, right? Now this at this place, this gigabit wireless scenario provides amazing user and experience and also high data rate. Now through this gigabit wireless, one can imagine VR, virtual reality office, like this. This is a virtual reality office. Now through this gigabit wireless we can imagine virtual reality office, right? Now the gigabit wireless is used where we require high amount of data rate, like dense urban information society. This is the place where we require high amount of data rate. Now at this particular place, this usage scenario of 5G will provide amazing end user experience with high amount of data rate, right? Now through this gigabit wireless we can imagine virtual reality office, like this. We have under this figure I have represented. Through this gigabit wireless we can imagine VR office. These are the features of gigabit wireless. That means where this gigabit wireless is used, where we require high amount of data rate. At this, like we have dense urban information society, it is a place where we require high amount of data rate. At this particular place, this gigabit wireless usage scenario provides amazing end user experience with high amount of data rate. Now through this gigabit wireless usage scenario we can imagine virtual reality office, like this, right? Now this is about gigabit wireless. Coming to the next slide, we have next usage scenario of 5G, great services in crowd. Next usage scenarios of 5G, great services in crowd. If you see this figure, now this is a stadium. This is a stadium where there is a gathering of more large number of people or more number of people. Now this is a shopping mall. Shopping mall also we may expect more large number of people. Now this is a open air festivals where we can expect more number of people. Now if these are the situations under 4G, now we may not connect call to the other persons at this particular places. We may not connect or call to, because there will be a fluctuating in your signals, right? Now this is overcome under 5G. This situation, this particular thing you are overcoming under 5G. Now this 5G provides great user experience even in crowd, right? Extreme traffic densities, dynamic in time and space, like shopping mall, stadium, open air festival. That means if there are places where a more number of people can gather, like open air festivals, stadiums, shopping mall, these are the places where there is a chance of gathering more number of people. Now at these places sometimes we may not get we may not connect your calls to the other persons, right? We may not connect your calls to the other persons. This drawback is overcome under 5G. Now 5G provides, though there is a crowd in a small area, the 5G provides great services at this particular open air festival, stadiums and shopping malls. Through 5G we can access we can get access to the calls to your family members in the places like open air festival, stadiums and shopping malls, right? That means what I want to say is, there are places where more number of people will be gathered. At that places also 5G provides its services, but this is absent under 4G or 3G, right? Now this is one more usage scenario. And next we have super real time and reliable. If you see this figure, you will get a clear idea. Now this is the present situation on the roads. Now using 5G, this will be the expected thing, right? Now traffic efficient and safety, more efficient use of road infrastructure, reduce risk of traffic accidents. This you are expecting in future by 5G. This is the present situation. Now this we are expecting in future by the 5th generation system, because low end-to-end delay and reliable communication enabling critical machine to machine. Because of this low end-to-end delay and reliable communication, we can enable critical machine to machine communication also, right? Now the super real time, nothing but low latency and highly reliable. Super real time and reliable is nothing but low latency, and this is one of the application. We have many application through which you can sort out the things. This is one of the application I am saying, one of the application of the usage scenario, super real time and reliable of 5G. Super real time and reliable is usage scenario of 5G, through which you can control the things. What I want to say is, super real time and reliable is the usage scenario of 5G, which provides low latency and high reliability, through which you can control things like this, right? One of the example I have considered, this is the present situation on the roads. In future, using this usage scenario, we may expect reduced risk of traffic accidents and efficient use of road infrastructure, right? This is the one of the application, right? Now coming to the next slide. Now here we have machine type communication. Next we have machine type communication. What is machine type communication? Communication between machine to machine. That means there won't be any user interference or there won't be any human interference, right? Now this machine type communication denotes broad area of wireless communication with sensors, actuators, physical objects and other devices which are not directly operated by the human, right? Which are not, that means this machine type communication includes sensors, actuators, physical objects and other devices, any device that is not directly operated by the human. As I have said, communication is between machine to machine, and those machines should support for more number of days. The battery life should be high, long battery life device. These are the applications where we are using machine to machine communication. Industrial, under industry we can use M2M communication. Under manufacturing, remote monitoring. Next we have billing, robotics, security, automotive, and next we have logistic management, traffic control, telemedicine, utilities. All these are the applications where we can use machine to machine communication. What is machine communication? Machine type communication is nothing but communication between machine to machine. Now that includes devices which are not directly operated by the human, like we have sensors, actuators, physical objects and other devices. All these are included in the machine type communication, which are not directly operated by the human, because under machine type communication there is no user interference. That's why it includes, under machine type communication we can use any any device, but that device should not get operated by the human, that device should not get operated by the human directly. Now this should support long battery life, machine type communication should support long battery life devices. Now these are the application: industrial, manufacturing, remote monitoring, building, robotics, security, automotive, traffic control, telemedicine. These are the applications of machine type that means these are the places where we can use machine type communication, right? Now what is machine type communication? Nothing but communication between machine to machine. Now this denotes broad area of wireless communication. This machine type communication denotes broad area of wireless communication, which includes sensors, actuators, physical objects and other devices which are not directly operated by the human. That means there is no user interference or human interference. Now since this communication is between machine to machine, those machines should support for more number of days. That's why the battery life should be also high, right? We have some applications where we can use machine type communication, like industrial application, manufacturing, remote monitoring, building, robotics, security, automotive, traffic control, telemedicine. These are the places where we can use machine type communication. Now coming to the next slide, we have tactile internet. One more usage scenario that we have is tactile internet. Now through this tactile internet usage scenario, user can access internet at very less amount of delay time. That means tactile internet as a internet network that combines ultra low latency with extremely high availability, reliability and security, right? Now this tactile internet as an internet network, now that should provide very low latency with high availability, high reliability and high security, right? Now the low response time, it should provide low response time, as I have said, low delay time, nothing but 1 millisecond, and high availability of 99.99%. Now the some application areas like automation industry, gaming, healthcare, virtual reality, these are the places where we can use tactile internet, right? Now this contains three modules. One is master domain, right? Another one is network domain. Tactile internet contains three modules: master domain, network domain, control domain. Under master domain we have tactile users. That means the users, those who want to access to the internet. The users, those who want to access to the internet, those are under your master domain. Under network domain, here we have internet network and access network. Under access network we have tactile support engine. Under access network through which you can provide very less delay time, and through this tactile support engine we can control devices under real time. And next we have control domain, like teleoperator, anything, those who are under controlling, those that will come under this control domain, right? This is the actual figure of tactile internet, right? What is happening in this actual figure of tactile internet, those are represented in this slide. Now what is meant by tactile internet? It is an internet network. The tactile internet is an internet network that combines ultra low latency with extremely high availability, reliability and security. That means it should provide low latency with high availability and high reliability and high security also. The response time should be less. That means user can access to the internet with very less amount of delay, and it should be very high, it should provide very high availability of 99.99%. Now the some of the applications areas of tactile internet include automation industry, gaming, healthcare, virtual reality, etc. These are the places like automation industry, gaming, healthcare, virtual reality are the places where we can use tactile internet. Now this includes three modules: master domain. Under master domain, those who want to access to the tactile internet, that are included under the tactile users, nothing but those are included under master domain. Under master domain, tactile users will be there. That means the users, those who want to get access to the tactile internet. Under network domain, we will have the network. Under this only the tactile support engine will be there. Next we have control domain, like controlling things, controlling operators are those will be under this particular domain. We have two domains: user and network domain and control domain, right? This is how the tactile internet we can use. And coming to the next slide, we have enhanced mobile broadband through 5G new radio, right? Why we require enhanced mobile broadband, that we will see in this slide, right? Now as I have said, the 5G should support improved spectral efficiency, right? Improved spectral efficiency. Now that spectral efficiency should be 3 times of spectral efficiency if you compare with the 4G. Now it should handle more amount of traffic. As I have said in the previous slide, the 5G should handle should the 5G should handle more amount of traffic. Now that traffic should be 100 times of traffic if you compare with the previous generation. Now we require enhanced mobile broadband. In this particular slide, it is shown that why we require enhanced mobile broadband, right? We require enhanced mobile broadband for 5G for speed. One is for speed, and another one is for 10 times experienced throughput. That means all these values are in comparison with the previous generation, that is 4G. If you compare with the 4G, the throughput should be 10 times of throughput of 4G for the 5G, right? Fiber like speed that is to be supported by the 5G, and the 10 times decrease in end-to-end latency. The latency should be decreased, and 10 times increase in connection density. That means more number of devices can be connected to the that means 5G should be in a position to get connected to the more number of devices. And next we have lower latency, that is spectral efficiency should be 3 times more and 100 times more of traffic capacity. And next we have network efficiency, lower cost per bit 100 times network efficiency. In order to provide all these parameters that are to be supported by the 5G, we require enhanced mobile broadband, right? 5G requires enhanced mobile broadband in order to improve the throughput, and in order to increase the connection density, and in order to decrease the end-to-end latency, and in order to improve the spectrum efficiency, and in order to improve the traffic capacity, and in order to improve the network efficiency. For these parameters can be achieved for the 5G through enhanced mobile broadband, right? Through enhanced mobile broadband we can achieve these particular parameters that are to be supported by the 5G. And next we have usage scenarios of IMT 2020, nothing but your 5th generation system and beyond 5th generation system, right? Mainly it is discussed in 3 modules. One is enhanced mobile broadband. Why we require enhanced mobile broadband? We require enhanced mobile broadband in order to improve the spectral efficiency, network efficiency, traffic. All these things are to be improved for the 5G if you compare with the 4G, right? Now these usage scenarios are mainly categorized into 3 modules. One is enhanced mobile broadband, and next we have ultra reliable and low latency communication, and next we have massive machine type communication, right? Whatever the usage scenarios that are there under for 5G or the IMT 2020, those are categorized into 3 main modules. One is enhanced mobile broadband, ultra reliable and low latency communication, and massive machine type communication. Now this enhanced mobile broadband, it can be used in the area with high user density. This enhanced mobile broadband can be used in the area with high user density and very high traffic capacity is needed. And next we have low mobility, high user. These are the places where we require enhanced mobile broadband. These are the places where we require the usage scenarios of enhanced mobile broadband. Now coming to the ultra reliable and low latency communication. Now this includes wireless control of industrial manufacturing, right? Now this usage scenario, ultra reliable and low latency communication, can be used under wireless control of industrial manufacturing, production processes, remote medical surgery. These are the applications where we can use ultra reliable and low latency communication. Distribution automation in a smart grid, transportation safety, etc. These are the places where we require a scenario of ultra reliable and low latency communication. Now coming to the massive machine type communication, under this communication there will be large number of connected devices and transmitting low volume non delay sensitive data. Under this machine type communication, we are transferring non-delay sensitive data, and devices should be of low cost and should have long battery life. As I have discussed some features of machine type communication, it should, the cost should be low and it should support long battery life, right? These are the some features of the places where we can use this usage scenarios, right? Now the mainly the usage scenarios of 5G IMT 2020 and beyond nothing but 6G or 7G. Now the mainly usage scenarios of 5G and beyond can be categorized into three modules. One is enhanced mobile broadband, and another one is ultra reliable and low latency communication, and another one is massive machine type communication. These are the three modules in which the usage scenarios of 5G or beyond 5G are categorized, right? Now coming to the first module of usage scenarios of IMT 2020, we have enhanced mobile broadband. Now this enhanced mobile broadband, where we require in under the area with high user density and very high traffic capacity, low mobility and high user data, right? Now these are the places where we require enhanced mobile broadband. Now coming to the ultra reliable and low latency communication, now some applications where we require, that includes wireless control of industrial manufacturing, production processes, remote medical surgery, distribution automation in a smart grid, and transportation safety, etc. These are the places where the usage scenario of ultra reliable and low latency communication can be used. Now coming to the machine type communication, now under this machine type communication we get connected more number of devices. Large number of devices are getting connected under this particular communication, and we are transferring non-delay sensitive data. Under machine type communication we are transferring non-delay sensitive data, and the device cost should be low and it should support long battery life, right? Now the future now to this existing system new features can be added, new features can be added if you go for 6G or 7G, right? These will be already included. In addition to this, we are adding some features if you go beyond 5G, right? Now this is about the usage scenarios of IMT 2020 and beyond. Now coming to the next slide, here we will see about capabilities of IMT 2020, right? If you see this figure, now the outer diameter is for your 5G communication, nothing but IMT 2020. Now the inner diameter, dark green is for your 5G, light green is for your 4G, right? Now the outer diameter is for the 5G 5th generation system, and the inner diameter is about IMT advanced, nothing but your 4G system. We will see one by one parameter. We will see. First we will see with spectrum efficiency. Now the spectrum efficiency should be 3 times more than the spectrum efficiency of 4G. What is spectrum efficiency? Average data throughput per unit of spectrum resource and per cell, right? Bits per second per hertz. Spectrum efficiency is nothing but average throughput per unit of spectrum, right? Now this spectrum efficiency should be 3 times more than the spectrum efficiency of IMT advanced. If you see, this light green is ended with 1 time and this outer diameter is ended with 3 times. That means the spectrum efficiency of 5G is 3 times more than the spectrum efficiency of 4G. This is one capability of IMT 2020. Now coming to another thing, now here the mobility of IMT advanced is 350 and the mobility of 5G is 500. Again the mobility is increased, right? What is the mobility? Maximum speed at which defined quality of service and seamless transfer between radio nodes or the radio access technology. That means between two radio nodes you are transferring the data at maximum speed with quality of services, right? That is nothing but the mobility between two radio nodes, seamless transfer of data at maximum speed with quality of service, right? And this mobility is 350 for IMT advanced and it is 500 for 5th generation system. Now coming to the latency. What is latency? The contribution by the radio network to the time from when the source sends a packet to when the destination receives. The time between the source sending the packet to the destination receiving that particular packet, right? That is nothing but the latency. Latency should be very low. Latency should be very low if you compare with the previous generation. What is latency? The time taken to deliver a packet from the source to the destination. The time taken by the time taken to deliver the packet, nothing but the amount of data from source to the destination is nothing but latency. Now this latency, it is 10 milliseconds for your IMT advanced, and it is decreased for your 5G, that is 1 millisecond. Now coming to the next capability, we have connection density, nothing but number of connected devices, right, per kilometer square, devices per kilometer square. Now this connection density is 10 power 5 for your IMT advanced and 10 power 6 for your 5th generation system. Number of devices per kilometer square, it is 10 power 5 for your IMT advanced and 10 power 6 for your 5th generation system. Now coming to the network efficiency. Next we have network efficiency. Now this network efficiency is 100 times more than the previous generation system. If you see this IMT advanced, it is only one time, it is multiplied with only one time. Now here it is 100 times. Now the network efficiency of 5th generation system is 100 times more than the network efficiency of 4th generation system, right? Now coming to the area traffic capacity. What is area traffic capacity? Traffic throughput served per geographic area, megabits per second per meter square, right? Its units are megabits per second per meter square. Nothing but throughput served per geographic area. The total traffic throughput served for geographic area is nothing but the area traffic. Now this value is 0.1 for IMT advanced and it is 10 for your 5th generation system. Again the traffic capacity is increased. Now the peak data rate. Next we have peak data rate, nothing but per user per device. Now this value is 1 for your IMT advanced and 20 for your 5th generation system. And next we have user experience data rate, nothing but megabits per second, nothing but achievable data rate that is available. Now this value is 10 for your IMT advanced and it is 100 for your 5th generation. If you see all the parameters, whether it is user experience or spectral efficiency or mobility, latency, connection density or network efficiency or area traffic capacity or peak data rate, all the values are better than if you compare with the previous generation system, all the values are better than with the previous generation system. User experience data is 10 times more than the 4th generation system. Spectral efficiency is 3 times more than the 4G, and mobility here it is 500 for 5G and 350 for your 4G, and latency is decreased 10 milliseconds for your 4G and 1 millisecond for your 5G, and connection density it is 10 power 5 connection devices per kilometer square for IMT advanced and 10 power 6 for 5G, and network efficiency of 5G is 100 times more than the network efficiency of 4G, and area traffic capacity is 100 times more. Here it is 0.1 for your IMT advanced and 10 for your 5th generation system. That means area traffic capacity is 100 times more than the 4G, and peak data rate is 1 gigabits per second for 4G and 20 gigabits per second for your 5G, and again user experience data rate it is 10 times more than the 4th generation system. All these are the capabilities that are in increased manner if you compare with the 4th generation system, right? Now coming to the next slide. Now this slide in this slide we will discuss about the importance of capabilities for EMBB, nothing but enhanced mobile broadband, and next you have URLLC, nothing but ultra reliable low latency communication, and next we have MMTC, massive machine type communication system, right? All the usage scenarios of 5G or beyond 5G are categorized into 3 modules. Now those includes enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication, right? Now if you see this particular figure, now these are the key capabilities that are important for most cases, but certain things are significant. If you see this blue color, this blue color is the parameters that are supported by the massive machine type communication scenario, and this light pink is supported by the ultra reliable low latency communication, and this enhanced, this somewhat green color, right, this is supported by the enhanced mobile broadband, right? Now the usage scenarios of enhanced mobile broadband requires the parameters of network energy efficiency, area traffic capacity, peak data rate, user experience data rate, spectrum efficiency, and mobility. These are the parameters that are required for the usage scenarios under enhanced mobile broadband, right? Now coming to the ultra reliable low latency communication, now this, the name itself indicates it should provide with low latency and high reliability. Now this includes the parameter of low latency with mobility, right? And the massive machine type communication, now this includes, now what it includes, it includes connection density, right? It includes connection density, and next it includes network efficiency, right? All the usage scenarios, what I want to say is, all the usage scenarios does not require all the parameters or all the capabilities whatever we have discussed here. Some require something, some require something, right? Now the usage scenarios of enhanced mobile broadband requires network energy efficiency, area traffic capacity, peak data rate, user experience data rate, spectrum efficiency, mobility. These are the parameters that are required for the enhanced mobile broadband. For massive machine type communication, we just require, because under massive machine communication we get connected to the more number of devices, that's why connection density should be there. Under ultra reliable low latency communication, we require low latency, that's why it requires the parameter of low latency. What I want to say is, all the parameters are not required for the all the usage scenarios. Some are required for something, some are required, only few are required for enhanced mobile broadband, that are figured out in this figure, and few are required for machine type communication, that are figured out here, and few are required for ultra reliable low latency communication, that are represented here, right? Now coming to the next slide, we have other capabilities behind this user experience data rate. We have, right, we have seen capabilities like user experience data rate, peak user experience data rate, spectrum efficiency, network efficiency, mobility, latency, area traffic. All these capabilities we have seen in the previous slide. Now behind these capabilities we have few more capabilities. Now that includes spectrum and bandwidth flexibility, reliability, resilience, security and privacy, operational lifetime, right? Now we have seen capabilities, different capabilities of 5G and beyond 5G, right? Now that different capabilities we have seen in previous slide. Now that includes latency, right, and that includes area traffic, and that includes connection density, mobility, spectrum efficiency, user experience data rate, peak data rate, network efficiency. All these are the capabilities that we have seen in previous slide. Not only those capabilities, we have some more capabilities that are to be supported by the 5G or beyond 5G. Now that includes spectrum and bandwidth flexibility. Now coming to the spectrum and bandwidth flexibility, now it includes flexibility to handle different scenarios, right? Using the spectrum and bandwidth flexibility, we can handle different scenarios, and it has a capability to operate at different frequency range, including higher frequency and wider channel bandwidth. Behind this capabilities, we have one more capabilities, that is spectrum and bandwidth flexibilities, where you can operate at different frequency ranges and you can handle different scenarios. Now next capability is reliability. Now it is the capability to provide a service with very high level of availability. Next capability is reliability. Now it is a capability to provide a service with very high level of availability. And next we have resilience. Now the ability of the network to continue operating correctly during and after the natural or man-made disturbance, right? Now if there is a natural disturbance or the disturbance that is caused by the man, now during that situation also it should be in a position to operate correctly, right? During the man-made disturbance or during the natural disturbance, at that positions also the network should be the network should get operate correctly. That is the meaning of resale. And next, it should provide security and privacy during the hacking position, right? Security and privacy areas such as encryption, integrity, protection of user data and signaling, end user privacy, unauthorized user tracking, protection of network against hacking. That means it should provide hacking, it should provide protection against hacking, security and privacy should be provided. This is one more capability that is to be supported by the 5G. That means it should provide protection against hacking. What I want to say is it should provide protection against hacking. And next capability is operational lifetime, operation time per stored energy capacity. Now this is important for machine type communication because it requires a very large battery life, approximately more than 10 years. Now this is a capability of machine type communication. Operation time per stored energy capacity. Operational lifetime is nothing but operation time per stored energy capacity. Now this is important for machine type communication. Now this is because we require a very long battery life, right? Now behind the capabilities, like we in previous slides we have seen capabilities like user experience data rate, spectrum efficiency, mobility, latency, connection density, network energy efficiency, area traffic capacity, peak data rate. All these capabilities we have seen in comparison with the fourth generation system, and what are the values under 5G we have seen in the previous. Now behind these capabilities we have few more capabilities. Now that includes spectrum and bandwidth flexibility. Now through this capability we can handle different scenarios. Through the spectrum and bandwidth flexibility we can handle different scenarios, and we can operate at different frequency ranges, different high frequency ranges. We can handle different scenarios and we can operate at different high frequency ranges. This is one more capabilities behind those capabilities which we have discussed in previous slide. And next we have reliability. Nothing but it is a capability to provide high amount of availability, high level of availability. And next we have resilience. Now during man-made disturbance or the natural disturbance, the network should be in a position to operate correctly. That is the meaning of resilience. This is the one more capability. And next capability we have security and privacy. That means it should provide protection against hacking, right? It should provide protection against hacking, right? And next we have operational lifetime. What is operational lifetime? It is nothing but operation time per stored energy capacity. Operational lifetime is nothing but operation time per stored energy capacity. Now this is important for machine type devices because under that machine type devices we require long battery life, that is expected more than 10 years. These are the few more capabilities behind that. And in the next slide we will see future technology trends in IMT system. What are the future technologies that we can expect in the future, that we will see in this particular slide, right? Now the first future technology that we expect is advanced modulation techniques and coding schemes. In future we may expect different modulation schemes and different coding schemes, right? Now those are influenced by the different deployment conditions like machine type communication, small cell indoor systems, etc., right? Now in future we may expect advanced modulation schemes and advanced coding schemes. And next we have NOMA, nothing but non-orthogonal multiple access, right? This is a future technology that we are expecting it. Already it came into existence, right? Now the orthogonal multiple access cannot achieve the sum capacity of multi-user system. Now this is the main disadvantage of orthogonal multiple access, that is it cannot achieve the sum capacity of multi-user system. Now the NOMA can increase user capacity and throughput performance by allocating the same radio resources to multiple users. That means, what is the disadvantage of orthogonal multiple access is that it cannot achieve some capacity of multi-user system. Now this can overcome under the non-orthogonal multiple access, through which you can increase the user capacity and throughput performance by allocating the same radio resources to the multiple. That means you are allocating the same radio resources to the multiple users, through which through which the capacity will be improved, throughput will be improved. And next we have advanced antenna and multi-site technology. These are the future technology trends of terrestrial IMT system. Now the first thing we have is 3D beamforming. 3D beamforming. Now we have a tall buildings, nothing but there will be high-rise buildings, nothing but we have a tall building. Then if one can provide a 3D dimensional sectors, then there is even more aggressive reuse of spatial reuse of the frequency, right? Now we have tall buildings. At that situation, if we are providing a 3-dimensional sectors, we can even more reuse the spatial reuse of the frequency. That is the main advantage of 3D beamforming. And one could provide better coverage to indoor situations in a dense urban situation, right? One could provide better coverage to indoor situations in a dense urban situation. These are the advantages which we are acquiring for the future technology trends of IMT system. One is, we can expect advancement in the modulation techniques, and we may expect coding schemes also, and we expect non-orthogonal. Already this came into existence. Now what is NOMA? We are allocating same radio resources to the different multiple users, through which you can improve the capacity and throughput. Now through 3D beamforming, right, we have tall buildings. At that tall buildings, if you are providing a 3D dimensional sectors, where we can aggressively reuse the spatial reuse of aggressively reuse the spatial frequency. Now one can provide a better coverage area in dense urban system. Because of this advanced antenna and multi-site technology, we can provide better coverage to indoor situations in a dense urban situation, nothing but the tall buildings, right? And next we have active antenna system, right? This is one more future technology. Now the RF components such as power amplifier and trans receivers are integrated with an array of antenna elements, thereby providing improved performance and reduced energy consumption. That means whatever the RF components we have, such as power amplifiers and transceivers, nothing but transmitters and receivers, are integrated. Those are integrated with an array of antenna. That means power amplifiers and transceivers are integrated with an array of antenna. This provides improved performance and reduced energy consumption, nothing but active antenna system. Under this active antenna system, we are integrating power amplifiers and transceivers with an array of antenna. This provides improved performance and reduced energy consumption. And next one is massive MIMO. You already know. Now this provides very large number of antennas that can be packed into a small space, right? Very large number of antennas that can be packed into a small space, hence suitable for pico or hotspot cell. Now this massive MIMO is suitable for pico or hotspot cell. Now through this massive MIMO we acquire high beam gain, right? Now next future technology trend of IMT system is simultaneous transmission and reception. Simultaneous, that means at a time we are transmitting and receiving the data. Now this thing can be achieved by same frequency band with self interference cancellation and providing doubling capacity of cellular network. These are the two things through which you can achieve simultaneous transmission and reception. Now coming to the next thing, we have technologies to improve network energy efficiency. That means what are the technologies that are there for in order to improve the network energy efficiency, that we will see. Now the methods to reduce base station energy consumption can be, one of the technology is to reduce the base station energy consumption. That means we will see the different methods. Those are those are responsible for reducing the base station energy consumption. That is the one that is the one of the way through which you can improve the network energy efficiency. And next thing is energy efficient network deployment and the traffic. And next we have the cost of the energy to operate the network is the operational expenses. That means the cost of the energy to operate the network. Now the bit per joule is a suitable. These are the different techniques through which you can improve the network energy efficiency. One is to discuss about the methods to reduce the base station energy consumption. This is the main thing through which you can improve the network energy efficiency. And next one is energy efficiency network deployment. Bit per joule is a suitable performance metric, and the cost of the energy to operate the network is an operational expenses. That means we can decrease the cost of the energy. Now coming to the network densification. Now what is densification? We know that. Now the cell miniaturization and densification is most favorable way for in order to enhance the capacity. Reducing the cell size and densification is one of the favorable way, right? And wireless backhaul, which is flexible when you compare with the fixed backhaul. And next we have ultra dense network making SOA, nothing but self optimizing network. Ultra dense network making self optimizing network provide a better spectral efficiency, support more connection density. That means more number of connected devices can be there. And we have larger traffic area. Traffic is also, that means it will be in a position to handle more amount of traffic. These are the future technology trends of INT system, right? We will see one by one in detail. We are expecting advanced modulation techniques and coding schemes. And next we have future technology is NOMA. Through NOMA we are allocating same radio sources to multiple users, through which you can improve the capacity and throughput performance. And next one is 3D beamforming. Now through 3D beamforming we can provide better coverage to indoor situations in a dense urban situation. Now we have a tall buildings. If one can provide a 3D dimensional sectors at that particular situation, now we can aggressively reuse the spatial frequency. That is the main advantage of 3D beamforming. If there are any tall structures at that particular place, if we are in a position to provide 3D dimensional sectors, then we can aggressively reuse the spatial frequency, right? Now one can provide better coverage to indoor situations in a dense urban situation. And next we have active antenna system. That means power amplifiers, transceivers are integrated with an array of antenna, which improves the performance and reduce the energy consumption. And next we have massive MIMO, nothing but more number of antennas that can be packed into a small area. And now this is suitable for pico or hotspot cells. Now through massive MIMO we can acquire high beam gain. And next we have simultaneous transmission and reception. Nothing but we have two different techniques through which you can transmit and receive the data simultaneously. Now same frequency band with self interference cancellation is one method through which you can receive and transmit the data at a time. And providing double capacity of cellular network. That means you are increasing the capacity by 2 times. These are the two methods through which you can simultaneously receive and transmit the data. And we have different technologies to improve the network energy efficiency. Now that includes methods to reduce base station energy consumption, right? We have to discuss about the methods that are responsible for reducing the energy consumption at the base station. And next we have operational expenses. That means the cost of the energy to operate the network is a part of operational expenses that can be is also removed in order to improve the network energy efficiency. And next we have bit per joule is a suitable performance metric. These are the different ways through which you can improve the network energy efficiency. And next we have network densification. Now reducing the cell size. By reducing the cell size and densification, these are the methods, these are the favorable methods through which you can improve the capacity, And next thing is that wireless backhaul. This is flexible when you compare with the fixed backhaul. And next way is ultra dense network making self optimizing network. Now if you make ultra dense network as a SON, now this provides better spectral efficiency and support more connection density. That means you can connect more number of devices. It can provide better spectral efficiency, and it will be in a position to handle more amount of traffic, right? Now this is about the usage scenarios of now this is about the usage scenarios of 5G, right? We have seen till now, we have seen different usage scenarios of 5G. In the next lecture we will see about the basic signal model, right? We will start about the 2G waveforms under 2G, waveforms under 3G, waveforms under 4G. After that we will go for the waveforms under 5G, right? Till now we have seen introduction to 5G, usage scenarios. We have seen 2G, introduction to 2G, introduction to 3G, introduction to 4G, and we have seen usage scenarios, and we have seen what are the capabilities of 5G. All this we have covered till now. In the next lecture we will see the basic signal model starting from 2G. 2G, after that we will see 3G, after that 4G, and later we will see about the frame structure and waveforms under 5G, right? Thank you.